Okay, let's say that this is my parabola. What is the y-intercept on this parabola? -2, or 0, -2. And what are the x-intercepts? No. 1, 0, and -1, 0. Okay, what is true about all y-intercepts? Like if it was right here, it'd be 0, -1, or 0, 1, or 0, 2. They all have a 0 as an x value. So all y-intercepts happen when the x value is equal to 0. Okay. What do all x-intercepts have in common? Yeah, the y value or the function value. The y value or the function value is always going to be 0 for any x-intercept. Okay, yesterday, what did we call these points where it hit the x-axis? Do you guys remember? Well, we called them the zeros of the function. More specifically, the -1 and 1 part are the zeros of the function because they are the values that make the function equal 0. On a graph, they are the x-intercepts. But if we plug them in the function, whatever the function is, like this function looks like it's like 2x squared minus 2. Okay, if we plug these in right there, we should get 0. Okay, so to do number 23, it's, 17. 17, it says find the x and y intercepts of the function and then graph. So we still need that graph paper from yesterday. It says g of x equals. It's not bad. It's kind of combining other stuff we've done already. Okay, how do I find the y-intercept? Okay, earlier, what did we say about y-intercepts? The x value is always 0. So it's kind of like when we do our table. If I put 0 in for x, whatever comes out for y, that's going to be my y-intercept. So if I put 0 in for x on this one, what do I get for y? 6. By the way, the g of x and the y, those are interchangeable, right? So, yeah, when I plug in 0, I get y equals 6. So that's going to be our y-intercept. Now, how do we do x-intercepts? Remember what we said? The y value should equal 0. So we're going to put like a 0 right here where the y was, or the g of x was. In other words, we do what we did yesterday. We just make the whole function equal to 0. And how do we solve this? This is what we did all last chapter. Factoring or quadratic formula. This looks like it might factor easy because what multiplies into 6? That adds up to 5. 2 and 3. So it's x plus 2, x plus 3. What x values would make this function equal 0? -2 or -3. Now on the graph, that would be like the point when x is -2, the function is 0. When x is -3, the function is 0. So as ordered pairs, that means -2, 0 is going to be the x-intercept, -3, 0. So basically what we're going to do is graph these three, 0, 6, -2, 0, -3, 0. And we're going to make a parabola out of that. So 0, 6, kind of high. 1, 2, 3, 4, 5, 6. -2, 0. How is that going to be a parabola? Does anybody think they might see it?
Not making a parabola.
It does make a parabola.
Is it that way?
No, it's not sideways. No. All right. Well,
It's just really narrow.
here's a hint. Oh gosh, just everybody move. Just
Why is it?
I think, I don't know, was it Monday or something? Yeah, Monday. We talked about how we could find the vertex when it's in standard form. You guys recall that? Maybe not. Remember this? Negative b over 2a. Was that Monday? Did we take a test on Friday? Yeah, it's Monday. The front part, remember the front part of the quadratic formula? It can be used to find the middle of the graph. So negative b is negative 5. 2a is 2 times 1. So the vertex is at like negative 2.5, negative 5 over 2. Well, how do I find the y value that goes with that? Plug it in. Plug that in for x. It's kind of a mess. You could do it in the calculator. I believe it came out as negative 1/4 or negative 0.25, you could say. So where's that on the graph? Negative 2.5, negative 0.25.
Bro. Dang,
Okay.
that's a big dip.
Now, do you guys see the parabola?
Yeah.
All right, it's this is the vertex though. Now, the vertex is always going to have to be halfway between the x-intercepts because it has to be symmetrical, basically. Anyways, it looks like that. It's just barely below the x-axis. Okay. Now, let's see how much we remember after doing it once. It's okay if you don't have it all figured out yet. It takes a few practice rounds. You guys, before I do this one, do you guys know what this parabola is going to look like? What's that tell me? It's down and steep. Down and very steep. Okay, so the first thing they asked is the y-intercept. Now, how did we do that earlier? Y-intercepts all have what?
3.
A 0 for the x value. So if you plug in 0 for x, that's 0. This term is 0. This term is 0, and that's a 3. Yeah. That number off to the side will be the y-intercept, 0, 3. Okay, how did we find the x-intercepts? Right, put in a 0 for the y, which just means you make the whole function equal 0. So it's kind of like this. We're putting in 0, like right here, and solving this. How could we solve this?
That's a great question.
Well, if it looks hard, what's maybe the best way to do it? Quadratic formula. Now this one does factor. Would you guys rather factor or quadratic formula?
Factor.
Okay. I don't want this, if I'm going to factor, I don't really want this to be negative, so how do I fix that? Multiply everything by negative 1. You don't really need, you could move everything to the right, but that's just a lot of work. What probably goes in the front? 2 and 2, maybe? Let's try that. Kind of have to do trial and error. What might go in the back?
3.
3 and negative 1?
Yeah.
What? Let's see. And how do we see if that works? Outside, inside of the FOIL. The inside is 6x. The outside is minus 2x. And that makes 4x. So that is right. Okay. And then x equals what? To make negative 3/2 or positive 1/2. So those are the x intercepts. Negative 3 halves. Where's negative 3 halves at? 1.5, yes. Okay, let's graph those 3 points and draw. So you can figure out what the problem looks like. Dang it. I don't know why I can't do a vertical line very well. Starting up 3, but we're going down quickly. So negative 3 halves 0 is negative 1.5, 0, and 1 half 0. So what's this going to look like? Now, is this going to be the vertex right here? No. The vertex is basically always going to be halfway between the x-intercepts because it's got to, that would make it symmetrical. It's got to be symmetrical. So the vertex must be probably about right here, I would guess. So it's going to look something like that. I didn't do a very good view there. Just got to kind of make it hit all 3 points. I don't know, we'll call that good. All right. 21 and 22 are a little bit messy. No, definitely not. Because I'm not giving you that much work to do. They do kind of take a while, but it's not still not that much. H of x equals negative 1 half x plus 4 squared plus 3. Okay, well, this one's written in vertex form. If we were graphing normally, that would make it easy. Okay, how do I find the y-intercept? Make the x 0. To find the y-intercept, you make the x value 0. If I put in 0 for x, 0 plus 4 is 4, squared is 16. Negative a half of 16 is negative 8, plus 3. Anya, you have cat socks. Reminds me to look at Caden. What's Caden wearing today? Oreos. Why are there food-related sock items?
Mine shoes are better. It's
anime. They make anime shoes? Where'd you put that on there yourself?
It's because it's orange.
Those socks look very warm. I think my feet would be sweating. Still. All right, that is going to be our y-intercept. How do we find the x-intercepts? Yeah, make it all equal 0 and solve. Okay. Well, this is not in standard form, so we can't. Well, we could do like quadratic formula, but we'd have to do a lot of work to find our a, b, and c. How have we solved these in the past? Okay, you want to get the parentheses, the squared thing by itself, and square root both sides. That's the easiest way to do it. got minus 3. Okay, a lot of you yesterday asked on a similar problem, can we just distribute this -1/2? And I said no, because exponents have to come before multiplication. So if you broke this up into like x plus 4 times x plus 4, then you could distribute the 1/2 on both of those. But that's not the easiest way to do it. The easiest way to do it is just get rid of the -1/2. How do I get rid of -1/2? Divide. Dividing by -1/2 is the same thing as multiplying by -2. So, -3 times -2 is 6. See how much simpler it looks now? We're getting close. How do I get rid of that square now? Square root. Square root. That's what Corey says.
I knew there was something with the other class, but I didn't know
I see it sometimes. I don't know if it's
Why are you trying to be different?
Are you trying to be ugly?
Dang. Are you trying to be
Every day. Like 100. I'm sure if you say it 7 times in this class, it's like 1,000 times a day.
You should start counting.
No. It'd make me sad. Okay. So we got x plus 4 equals what? Most of you got it wrong on the test.
Plus or minus square.
Plus or minus square root of 6. All we need, yes you did, you wrote plus or minus, then you erased it.
That was great. That was also me. That wasn't me, I actually wrote down.
That was Caden.
Yeah.
Wow.
I
Did
really
you call him Raiden?
Right.
Yeah, right.
Braden?
Plus or minus square root.
Actually not. I'm with him.
Yeah, same.
What? What'd you say?
I don't care. I'm just it's
Is that
better.
Don't have to
Wait,
correct.
I'm not the only mistake.
He's just gonna go watch the video.
Yeah, me too. It was supposed to be like minus 2, but I did plus or minus 2. No, and then because we.
Okay, and those don't really mix.
And I remember I solved it and I got -2, but I thought he wanted the plus or minus, so I kept plus or minus. Yes.
Oh, did you put plus or minus on the quadratic formula problems? And you weren't supposed to?
That's what you tell us, put plus or minus on everything. It was a square root.
No.
Everything was
No.
square root.
Stupid.
No. That's not on quadratic. Well, it happens on quadratic formula, but
I didn't see that.
I'm sorry. That's like you are too. Then.
remember we had you go in the calculator, make it a plus, then go back and make it a minus. Gave you 2 different answers. Okay, the plus or minus thing happens when you square root both sides. Alright. Now, what the heck does this mean? This means that's the x-intercept. -4 plus square root of 6, 0, and well, how are we going to graph that though?
You gotta put it in your calculator.
Put it in the calculator and change it to a decimal. So somebody needs to plug that in the calculator.
How many?
It's probably 2 point
A
something.
million.
Next year we're probably
When you do like the -2a, plug that in.
Eli day.
We can talk about doing the quadratic formula.
No, like it'll be like
And
-2a,
99.
give them.
Oh, shh. Yeah, the -b/2a tells you the x coordinate of the vertex.
So plug it in as x.
You put it in for x to find the y that goes with it. Yeah. Does anybody plug this in the calculator?
Nerd.
Somebody do it.
I'm doing it in my brain. It's like 2 point something.
All right, then you guys are on your own. You can finish it yourself.
It's like 2.2 plus 4. Really slow.
You got this for
All right.
Alright.
Shh. All right, I need to have this.
Gash.
-1 point.
Gash.
Five.
And
-6.4. Now, were you rounding correctly on the 5 and the 4? I can't remember the answers. So.
Wow, got correction.
Okay, so this would be 6. And what about this? 4, 9? Like 4, 4, 9 or just 4? 4, 4, 9? Okay. Alright, so on you plug these in the calculator. Shh, hush. And she got these decimals. So that'll tell us where it goes on the graph. It's kind of way out to the left, negative 6.4. So the y-intercept was 0, negative 5. It's been a long time since we did it. 1, 2, 3, 4, 5. And the x-intercepts, negative 1.6, negative 6.4.
Help those of us who have been together.
Okay, where must the parabola be? Well, the vertex must be somewhere in there, right?
How do you know how high up to
And
go?
I'm just guessing, based on what it looks like. Actually, we could kind of find the vertex.
I take it back.
We could find the vertex really easy. I think I got really close. Because what's the vertex? Negative 4, 3. So I pretty much nailed it.
Down in Ohio.
Sorry. Are you spinning or no? Okay.
And then to, I can't control, I can't control feelings.
I don't give you that. I need to reduce it. Next.
This meant to be deals.